This video is about finding local minimum and local maximum value of function using first derivative test. So let's begin.
In order to accurately apply this test, keep in mind the following steps. Step 1. Find the critical points of the function. Step 2. Divide the x-axis into intervals based on critical points. That is, if we have 2 critical points, then the number of intervals will be 3. And if 3 points, number of intervals will be 4. And so on and so forth. Step 3. Choose one point from each interval formed. It can be any point. Just pick one point from each interval that you have formed in the step 2. Step 4. Evaluate first derivative of the function at the chosen point. And note down the sign of each point you have evaluated. Step 5. This step is important because it can be used to determine whether at a certain critical point local minimum or local maximum value of the function occurs. In order to find out that, keep in mind the following sign changes about a critical point. If sign of derivative changes from minus to plus about a critical point, it means that local minimum value of the function occurs here. And if the sign of derivative changes from plus to minus, it means local maximum value of the function occurs here. And if no sign changes occur about a critical point, neither local maximum or local minimum value of the function occurs at this critical point. So that's how first derivative test can be used to find local minimum or local maximum value of the function. So let's take an example to make things clear and see how the both steps can be applied. Example 1.3. Consider the function f of x is equal to x power 1 over 3 into x minus 4. If you inspect this function, then the domain comes out to be an open interval from minus infinity to infinity. Now applying the first derivative test step by step. So step 1 is finding the critical points. So the function f of x is equal to x power 4 over 3 minus 4x power 1 over 3. Taking its derivative, and then applying the sum rule of derivative on individual terms, then applying the power rule on each term. So the derivative function comes out to be 4 by 3 into x power 1 over 3 minus 4 by 3 into x power minus 2 over 3 by using the power rule. Now simplifying it, the derivative comes out to be this. And so that's the derivative function. Now to find the critical points, we have to set the derivative function equal to 0. So by setting it equal to 0, the critical point comes out to be x is equal to 1. So that's one critical point. Now to find the second critical point, what we have to do, we have to inspect the derivative function. That is, we have to look for the points where the derivative function is undefined. That is, it does not exist. So by inspecting, we find out that at x is equal to 0, this function turns out to be infinity. So the second critical point is x is equal to 0. So in step 1, the critical points we found are x is equal to 0 and x is equal to 1. In step 2, we have to divide the x-axis into intervals. So the critical points are x is equal to 0 and x is equal to 1, which are 2 in number. Therefore, the number of intervals will be 3. So the first interval is from minus infinity to 0, which is an open interval. It can also be taken as a closed interval. So it does not matter. Interval 2 will be from 0 to 1, and interval 3 will be from 1 to infinity. So these are our 3 intervals. And step 3, we have to choose one point from each interval. So choosing x is equal to minus 1 from interval 1, x is equal to 0.5 from interval 2, and x is equal to 2 from interval 3. So these are our 3 points. Step 4. Now evaluating the first derivative functions at each of these points. The points are x is equal to minus 1, x is equal to 0.5, and x is equal to 2. And the first derivative function is 4 by 3 1 over 3 minus 4 by 3 x power minus 2 over 3. At x is equal to minus 1, the derivative function comes out to be minus 2.66. So the sign of derivative in this whole interval is negative, and the interval is minus infinity to 0. At x is equal to 0.5, the derivative function comes out to be minus 1.05. So the sign of derivative function in this whole interval will be negative, and the interval is 0 to 1. At x is equal to 2, the derivative function comes out to be 0.84. So the sign of derivative function is plus in this whole interval, and the interval is 1 to infinity. Step 5. Identifying local extreme of points. So the critical points are x is equal to 0 and x is equal to 1. At x is equal to 0, which is the critical point, the sign of derivative is minus to its left and minus to its right. As derivative does not change its sign, therefore no local extrema occurs at x is equal to 0. At x is equal to 1, the sign of derivative is minus to its left and plus to its right. As derivative changes its sign from minus to plus, therefore local minimum value of the function occurs at x is equal to 1. So by using first derivative test, we have found out that at x is equal to 1, local minimum value occurs, and its value is equal to minus 3. So now coming to the graph of the function, from in the interval from minus infinity to 0, the derivative is negative, and at x is equal to 0, the derivative is undefined, that is the slope of the tangent line at x is equal to 0 is infinity. Similarly, in the interval from 0 to 1, the derivative is negative, and at x is equal to 1, derivative is 0, and in the interval from 1 to infinity, the derivative is positive. The local minimum value of this function occurs at x is equal to 1, and its value is minus 3. So that's how first derivative test can be used to find local minimum and local maximum value of a function and the location at which these occurs.
So thank you guys for watching this video, and if the video helped you, give it a thumbs up, comment any question you might have in the comment section below, and subscribe for more.